Welcome to the project demonstration of design of an inverter with the battery low and overload indication. So here we have the two features. One is whenever the battery is low, then automatically microcontroller will switch on the charging circuit, means charging voltage to this battery through this electromagnetic relay. So it's a battery low indication with auto charging, and also overload indication. So as you know that when we are using an inverter in our home needs, so when we are accidentally on heavy load into the inverter, then automatically the system will detect that, and also it will inform to the user about the overload was detected, means high load was connected on the inverter. So here the flow is, we are providing 230 volts AC to the transformer. So the transformer step down the 230 volts AC to 12 volts AC, and the input to this regulated power supply board. In this one we have the three stages. One is a bridge rectifier and filtration and regulation. Bridge rectifier to convert 12 volts AC to 12 volts pulsating DC, and filter to convert that pulsating DC to pure DC voltage. And there we input to the 7805 regulator. So 7805 nothing but which will take the above 5 volts and provide us the constant 5 volts. So that's the main operating voltage to our microcontroller. So here we are using PIC 16F72 microcontroller, which will interface between the inputs and output module. So in our project, inputs are voltage sensor to monitor the battery voltage, and current sensor. So this current transformer along with potential divider circuits, we called it as a current transformer. So these two are the input, and the outputs are electromagnetic relay and a buzzer. So this relay will get switched on whenever the battery voltage is low, and buzzer will get switched on for battery low as well as overload, and so-called status continuously displayed on the LCD screen. So we have interfaced these inputs and outputs at A0 to the voltage sensor, A1 to the current sensor, and pin number B2 to B7 for the 16:2 LCD screen, and next buzzer at C4 pin, and relay for C7 pin. So these are the inputs and output interfacing to this motherboard. So on this motherboard we have the three major components. One is the microcontroller and a crystal oscillator. The steel plated one is a crystal oscillator, which will provide the 20 mega clock frequency to the microcontroller. So the purpose of the clock frequency is, we have provided a set of instructions inside the controller, that is reading inputs and control the output modules. So each instruction need one pulse. So we are providing 20 mega clock frequency per second, so that controller can execute 20 mega instructions per second. And the next is the reset switch to restart the microcontroller. If is there an abnormality detected, means unnecessary buzzer on or relay gets switched on, then to reset that, so just hold and release. So then automatically the system will starting from the initial steps. So welcome message on the LCD screen, and then after voltage continuously monitored, and the load status is normal as there is no load, and the zero load is connected to the inverter. So coming to the inverter, so we have developed a 555 timer based inverter. So here the 555 timer purpose is to generate the 50 Hz pulses. So by taking 12 volts DC input, so we are using 12 volt 1 amp. So there we can see 4 volt 1 amp batteries are connected in series. So we will get 12 volt 1 amp, the output of this battery input to this inverting circuits. So when we provide this DC input to the circuits, the 555 timer, as we know that we can use that in three modes. One is astable and monostable and bistable. So in our project we are using that as astable multi vibrator, means continuously it will generate the square pulses. So that 50 Hz pulses will given as input to the gate of these two MOSFETs. So here we are using IRF 540 MOSFETs. So the purpose of this MOSFETs is, so the 555 timer can't handle the maximum current for the inverter. So that's why we are using these two MOSFETs as a switch between the direct 12 volts and a transformer. So the pulses to the gates, and the MOSFETs will convert that to 12 volt 1 amp current AC signal. So that is input to the our transformer. So here we are using step up transformer is 12 volts to 230 volts. So input 12 volts AC from this circuit, and output is 230 volts AC directly to the AC load directly. And here coming to the transformer, current transformer, which is connected in series with the load. So as we know that to measure the current, we should connect the current transformer in series to the load. So we'll get the current which was consumed by the load directly, and output of this current transformer is AC. So our microcontroller can't read the AC voltage. That's why we are using this potential divider circuit. So here we can see one bridge rectifier. This is DB107, which will act as a bridge rectifier only. So which will convert the AC to DC directly. And also here we can see the resistors. The purpose of this resistor is, so we may get up to 230 volts. Whenever the load increases, the voltage will be increases from 120 to 230 volts. So then the 230 volts AC will be stepped down to the around 10 volts with help of this potential divider circuits, and there to the DB107 bridge rectifier convert AC to pulsating DC, and this capacitor will remove the pulses, so we'll get the pure DC voltage. And after that the 10 volts DC will be stepped down again, stepped down to with potential divider circuits at 10:1 ratio. So control will get only 1 volt. Means whenever we are putting 10 volts here, the control will get 1 volt. So in that controller we have programmed in such a way that so it will be multiplied with the potential divider ratio, that's 10:1. So control will measure in that way. So this is a main flow. So directly let us see the demonstration. So as of now the battery voltage is monitored here. So whenever we switch on that, as we are connected as a high load and low load, so when we switch on the inverter, so low voltage usually and load is high, that will be displayed on the LCD screen. So normal load, as when we switch on the inverter, automatically the power will be consumed by the inverter will be more, that's why the voltage drops drastically. And for the low load, so for the voltage we have set the limits for 8 volts below is the low voltage and 13.5 is above high voltage. Whenever it crosses 13.5, then automatically this relay will get switched off. Whenever it is below 8 volts, then it will get switched on. And coming to the high current, we set the limit for 10 watts only. So as we are using 30 watts bulb, and also 10 watt is going to 0 watts. Remember, only 5 watts will be consumed by this bulb. And everything is normal now. Right.